Um, Good morning, good afternoon, good evening. My name is Tim Gergis. Pleased to present the Topology and Morphing improvements for 2025.1. So from the Topology side, one of the first things we're going to go through is performance. One of the things we've been focusing quite a lot on for the 2025.1 release is rebuild performance. So we've seen a significant improvement for rebuild. It's now, in some cases, 30 to 50% faster. This will affect any of the tools that use rebuild in the background, like box trim, cut hole, the bead tool, all of those sort of related tools. With the general improvement to rebuild, we'll see general improvement across the product when using any of the topology. So this is just a small graph indicating where we started in 2022.3 in a relatively small model, with a relatively small selection, relatively in a 5 million element model with 250 elements selected. This is the performance timings we've seen over the releases. So in this particular, so this is 2025.0, in a relatively unconventional duplicated model. I've got 24 budding whites stacked on top of each other. It's about 10 million elements. This is 2025.0. This takes about 3 minutes to complete a rebuild operation on, if we select just a small subset. So if we clear this and select by surface, we can perform a rebuild. And while that's running, we're going to switch to 25.1 and do the same thing in 25.1. So again, we're just going to select by surface. Now, this is disproportionate for the sake of being disproportionate. So 2025.0 is starting. 2025.1 is just about finished. Actually, it is finished. It's now updating the graphics. And that's done. So for now, I minimize this and we can wait. Or not wait, but this is now 25.0. So very, 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 very quick in 25.1 for a small element patch selection on a very large model. Again, this is disproportionately large, but this in recorded takes about 3 minutes. The only other change you should see for rebuild is if I jump back out while this is still thinking about what it's trying to do, is if you have the element quality turned on and you rebuild something with a washer, we will actually respect the washer, whereas historically you didn't get a washer. So again, just a small general improvement to the rebuild enhancements here, but what you should be seeing is a significant improvement to the rebuild performance. And again, just for context, I'll zoom back out. Come on, fit. No. Let's see if this works now. There we go. It's 24 body whites stacked on top of each other. Now, if we go back, no, still not finished. So your customers should see a significant improvement when trying to use rebuild in large models. Okay, we're just about finished. Almost there. No, still updating the graphics. And I think, hopefully, the 25.0, this should just about be finished. Okay, I think we can all agree that 25.1 is significantly faster, and I'm going to hand over to Salim. Salim?
Hello, everyone. My name is Salim, and I'll be talking about further developments in 25.1. With respect to the topology, I think one major topic is again the performance. In continuation to what Tim mentioned, we have also been focusing on the performance improvement for general meshing tools. In this page, we have the example of ruled. Again, this has to do with a larger database model. In this case, there is 5 million elements, and when we are meshing a surface created by ruled, it used to take about 15 seconds, and now the reduction to 5 seconds. So there has been a significant improvement in the performance. On the right side, you would see it's 3.5 million elements, and the difference is a little bit lesser when compared to the 5 million, because it really depends how big is your database, like what Tim was showing. So larger impact when we have a larger database model. Also consolidated the cleanup tolerance under topology preference. I think this was also problematic when we had automatic and manual options earlier. Automatic was always like you would just recall the tolerances the model was saved with. It really never recalculated or recomputed the tolerance based on model size. So we have removed that, and we have added a recalculate button for cleanup tolerances. So whenever user is say playing with the model of larger scale or models in meters, they could simply recalculate the tolerance based on the current dimensions, and the node tolerance also gets updated accordingly to the geometry. So whenever we are say topology editing or editing the mesh, uh, we won't see the distortions that we were seeing earlier in 25 just because of the tolerances. So I think with this, I will hand over to Preetham for further developments in 25.1. Thank you all.
Uh, Hello everyone, my name is Preetham Deshpande and I will be covering further enhancements in our topology tools. So as you can see on your screen, under split and stitch operations, we have added new option to split FE geometry for solids. On the left, you can see that, and surfaces on the right, using elements option. This is a very quick option where you can window select your elements as long as there's FE geometry and hex elements, you can split it. Obviously, we don't want to make any random cuts, but this is very easy when you are, doing, let's say, one row or two row or specific rows of elements. Using elements, you can split your solids. So definitely comes very handy. Further, we had split options of the surfaces using FE edges. Now we also have it for solids. As you can see that it kind of propagates that FE edge and acts like a plane, and it gives you a nice cut throughout the solid. So this is also very helpful, and it's also part of um, the efforts where we want to make all the tools work for FEH. And just taking this further, most of the node list options and nodes option, we do have issues down the line, and we want to address those by changing the selectors to FEH, which is very handy, and it kind of makes sense in the future. The other important enhancements and part of our consolidation efforts is we have migrated the old hole gap fill tool, and we have migrated portions of it into the tools that it really belongs. So hole fill and patch fill really belongs to the surfaces and patch operation, and gap more belongs to our rule operation. So we have moved the respective tools into that, which makes sense. Also, with support of FE geometry, most of the options under this tool, will come naturally under the patch and rule. And the other options like remesh or consider feature, we have put it under the guide bar options as well. So since now we are adding and consolidating these options, we also wanted to make sure that this is discoverable. So we have actually moved the patch tool from surfaces onto the main ribbon icon. So now you can go to 2D and directly see patch. So it becomes easily accessible. And we also have added a patch kind of initiator checkbox so that we can differentiate between the hole fill and patch fill. And the reason of doing this, as I said, we are consolidating tools, but also these tools apply to orphan mesh, especially this whole gap fill was, purely orphan mesh related. We also have geometry commands. We also have CAD. So all of the mix that we are putting this in the tool, so we are trying to organize it, in such a way that, it's easily discoverable and you can still trigger certain options based on the cases that you're handling. So here's an example, simple example, which is the most common use case I have shown here from the whole gap fill tool is that we can select and give a width. Now this is an orphan mesh and you can specify whole width. It will go ahead and find for all the components that I have selected and it will fill the holes. You can see that more than 2000 holes have been filled within no time using this patch fill for components. Now, this is a default option. You could also click on the mesh option to get a nice structured mesh for these filled holes. I think that's part will be coming. So same thing I'm doing. And with the improvements that Salim talked about, even this remesh will be speed up. So you can see that these holes are filled with more structured mesh rather than the default. Another most common use case that I want to show is the gap fill. So what we have done for gap fill is that the ruled option, basically we have added the missing selector. So one of the options that the tool had was faces, and we added faces tool into rule where you can select faces and fill this gap. Again, this is just pure orphan mesh that you can apply this tool to. Some of the other miscellaneous enhancements under the sketcher tool on the left, you can see we have added option to create a midpoint line. So you can see from the video that basically the click starts as a midpoint and it goes on both directions equally. So that's one of the options, small enhancement we added. And on the right, spline through point, this is more directly coming from customer request. And what we do here is that for the control point selection, spline also has two options. The top one that you see, basically we can create spline, and once the spline is created, you go into the edit mode. You can see that it is creating spline. Once you exit out of the tool, the created spline, actually you can select the manipulator appears to change the magnitude as well as the directions. So this is more of a global change that you can make to your spline. It comes in very handy for legends. Now I'll hand over to Natalia to take you through the exciting features enhancements.
Thank you, Pritam. My name is Natalia. I will go through the latest updates related with features. First of all, I want to highlight the removal of the feature manager window. All the information that was previously there has now been moved into the browser, resulting in a more streamlined workflow. This means that we will have no more duplicated information, and we will keep a consistent structure across all tools. All the existing options and functionalities from the feature manager remain available, and users can still work with the features exactly as before, just in a cleaner way. To give you a few examples, the entity editor info remains the same. The feature option is still available, and the features are still organized by type in the model tab, just like before. Do a quick update on flange detection improvements. Previously, flanges were detected using orphan elements, and this had as a result to lose the surface information and indicate random wrong elements as part of the feature surface. Now the detection is based on the FE geometry, and this gives a more accurate and reliable representation of the features. That was all from my side. I will hand over to Stefanos.
Hello everyone, I'm Stefanos, and I want to present to you what we are introducing as enhancements for Morphing in 2025.1. First of all, I have split the enhancements into two categories: miscellaneous enhancements and performance improvements. For miscellaneous stuff, we are introducing an option to export shapes as H3D files. Another improvement we did is the ability to map to FE geometry. Previously, only CAD geometry was a valid selection. Now you can also map to FE geometry. And this is a step towards unifying morphing with topology, be that CAD or FE geometry, and unifying also the workflows. So this is a step towards that direction. The third thing we are introducing is the inside the edit shapes context. You can automatically create either a design variable or a desvar card. Previously, you could only create desvar cards. Now, design variable parameters are also available to be automatically created for optimization. And lastly, skin elements are no longer needed. When morphing normal to 3D elements, we can directly pick faces of 3D elements and the normal direction will be calculated. Now for performance improvements, we have made various improvements across the entire morphing workflow, or at least a common morphing workflow, that mainly target large models. So interactive morphing for free morph has been improved. Undo-all performance has seen an improvement by approximately 50% for large models. The automatic calculation of anchors and morph area is faster. And also, we noticed that there were some delays in very large models when we tried to post the contexts, be that proximity morph, free morph, or volume morphing. So we have addressed that, and all the contexts load simultaneously. So they post up instantaneously, and there is no delay there. Regarding the H3D format, I have here a quick video showcasing this. So we can select a shape and export it. On the shape format, there is this option as H3D, which can be selected from the drop-down menu. What is good about this format is that we can load this into Hyper-V, for example, and we can use it to also animate it. We can animate it from the unmorphed state to the final morphed state as well, as you can see here. So it stores the perturbations that occurred within that shape. Here, for example, we have a very simple model. If I select the surfaces, this surface is an FE geometry surface, whereas this one is a CAD geometry surface. Previously, we could only map to this surface, but now, if I select some faces here, and I select this as the target, I can directly morph to the FE geometry. Then if I create a shape and undo all morphs, as you can see here in the edit shapes dialog, the design variable is now a drop-down menu instead of a checkbox, and we can choose between desvar or design explorer. Desvar is the same as it was before. It automatically creates a design variable card, whereas design explorer automatically creates a parameter to be used in optimization. If we turn these two off, it automatically deletes the parameter as well. So this is a step towards unifying optimization with shapes as well. And for the normal to 3D elements, Here we have a simple borehole model. Let's say we want to morph this and change the radius of the hole. Previously, we would need to use the skin elements on top of the 3D elements in order to be able to calculate the normal. But with these improvements that we introduced, we can directly select the 3D elements. And as you can see here, these elements are 3D. And we can directly select, let's say, the inner face, and the normal direction is calculated. For performance improvements, here I have 2 videos that evaluate the performance for a common morphing workflow applied to a part of a full vehicle model. On the left, I have the workflow with 2024.0 version, whereas on the right, there is the same workflow in 2025.1. I will begin with 2024.0. In this workflow, we first isolate some parts that we want to consider for morphing. Then we can select the moving nodes as well as do any alterations to the anchors or morph area according to our needs. As you can see, it takes some time for the calculations to be made. And now we want to morph this interactively. So just dragging the vectors to change the shape. Due to the size of the model, this is taking a long time and it's slow, laggy, and a little bit unresponsive. In the end, we create the shape, undo all morphs, hide the shape as well, and finally we can animate the shape within the whole model. Now the same workflow will be done using 2025.1. The steps are the same. We first isolate the parts that we want to consider for the morphing. And then we can select the moving nodes. It might not be too much noticeable, but the calculation, the automatic calculation was done faster. But the major improvement here is the interactive morphing, which is far more responsive. It's not laggy, and it gets us quickly close to what the value we wanted it to be is. So in the end, there is a 25-second difference for the workflow between 2024.0 and 2025.1. This might not look like a big difference, but this difference will be larger the larger the size of the model gets. So the larger the database is, the bigger the performance increase. So as I said, we implemented several enhancements to improve the performance in both free and proximity morphing. First of all, automatic calculation of anchors in morph area is faster for both free and proximity. Another key area is interactive morphing, as I said, for large models. Even if we isolated a small portion of the model in previous version, the process remains slow and unresponsive. Whereas in 2025.1, we have significantly improved the performance for free morphing when using node face or edge selectors interactively. And we are also working towards bringing these changes to proximity morphing as well. So right now, interactive morphing has been fixed only for free morphing, but we will bring these improvements to proximity morphing in the next release as well. And here I have a simple graph showcasing for each year the performance, how much the performance has increased. And we can see that from 25 to 2025.1, we have cut in almost 2 minutes for the workflow. Now, as I said, the impact of these changes is largely dependent on model size. with small models exhibiting minimal differences. As we can see, for a model of 300,000 nodes, the difference is only 10 seconds. Whereas for a model of 20 million nodes, the difference is close to 2 minutes. So that's a big difference. Morphing small models is already fast and responsive, and our goal is to achieve similar performance for large models as well. Naturally, the most significant factor affecting the execution time of morphing is the size of the morphing area and the number of nodes that need to be adjusted. These improvements specifically target the isolation and morphing of small regions within large models. So as illustrated in the graph, the model area is substantially smaller than the overall model of the size. So morph area is 10K nodes, 3K nodes, 15K nodes, whereas the size of the model is much larger. That concludes the presentation.